Okay. All right, let's get started. 3.2. What is the inverse of this? Right here. Okay. Do you know what you're looking at right there, by the way? Like, is that linear? Is that a linear function? No. What is it? Okay, yesterday we did a to the x. It's exponential, right? Okay, so it's exponential. Now, can we just pretend that a is greater than 1? If a is greater than 1, what do we know about the picture?
Increasing.
Is what?
It's increasing.
It's increasing. There's another name for that. You're right, John. It's growth. Okay, we got it. So guys, here's the deal. I'm asking for the inverse function of exponential. This one's growth, right? Okay, first of all, after yesterday, I'm sure you guys all know this. Isn't this the picture? Okay, now, I'm just going to ask you right now. Do you know 2 points on that graph right now? Yes. What is it, Alex? Give me 1 point.
0, 1.
Okay, Alex says, right here, 0, 1. Is he right? Well, let's check it out. Put 0 where? Invert x. A to the 0 is what? Always going to be 1, right? So he got it. 0 goes in, 1 comes out. There's another point on that graph you should know. 1a. If you put 1 in, a to the first is what? A. So 1 will go over 1, right here, and up what? A. So 1 comma a is always on the graph. And when I say a to you, are you thinking what? The base. Whatever the base is, it's 1 comma the base. Does that make sense? So what would this be? Give me 2 points on that graph. 0, 1. And what? 1, 5. You get it? That's it. So guys, when you do growth, you can do 0, 1 and 1, 5. Or 0, 1 and 1, 6. 0, 1 and 1, 7. You can do that. If you know it's growth, you just go like this. Okay? Now, help me out. I just want this now. I want the inverse function. John, what is it?
Would it be a log of x?
A log of x. No. You guys don't get into log. Don't say log. Because what you guys are doing is you're going like this. I think I know the inverse function of exponential log. So you're using the word log. Go back to chapter 1. In chapter 1, how did I say find the inverse?
Switch of the y and a.
Say it again.
Switch of y and a. So it's
Oh, not y and a.
X.
X. It's the point xy, switch xy. So what would this be if you switch xy? What does y become? X. What does x become? Y. Hey, that is the inverse function right there. All you have to do is switch what? Switch xy. This is the inverse right here. Inverse function of exponential. Exponential, meet the inverse. Inverse, meet the exponential. Okay, now here's the deal. Can you graph it?
Yeah.
How? Well, guys, come on. You know how to graph inverses. You flip the x and y, right. So you know what the exponential function looks like. So why wouldn't you just flip 0, 1 and call it 1, 0 right here. 1, 0. How do you flip that one?
A1.
A comma 1. Well, how far is A? Well, let's just pretend it's here. A comma up 1. And then you know what happens? Because they're inverses, they're reflections over what? Remember this line? Y equals x. Yep. Okay. And because they're reflections, guys, look. Goes like this. You know how those points go that way? These points are going to go that way. You know how that is your horizontal asymptote, y equals 0? Well, guess what happens? the inverse? It will be what? X equals 0. Yep. So now you have a vertical estimate. So here's the deal. The only reason I did that to you, I only did that to you because I want you to know there's an inverse to every exponential. There it is. Well, guess what they did? That's the inverse. So they decided to give it a name. You know what the name of this is? Log. They gave it a name. They gave the inverse a name. What's the inverse to exponential? Logarithmic. And now the next slide is all about the definition of a log. So let's go read it. And once we get this in our head, it's pretty simple. Okay? So what is this? What's a logarithmic function? Base A. Well, it's in red right here. This is what it is. That's it. It's y equals log base A of x. Now the way I read it to you is the way you say it out loud. How do you read this? Log base what? Little a of what? Of x, period. So how do you read this piece just like I read it to you? Log base a of x is how you read it. Equals what? Y equals y. Sorry guys, hang on. This. How come this always happens when I tape your class? Okay, then, yeah, ignore. Okay. And let's go. Okay. Hang on. Did I lose the whole thing? I might have. Still okay. Okay, let's go like this. Okay. Can I just reopen? Yes, recover. And that's where we were, right? Okay, so I didn't really lose anything. Now we just have a bunch of talk on there for nothing. Okay. Anyways, oh no, I was one more, wasn't I? I was right here. Can I get away with not writing all that out again? You okay with that? Okay, so here's the deal. This right here is what you and I came up with. Didn't we say this is the inverse? This is the inverse of a to the x equals y. So this is exponential, right? Okay, here's the inverse, and the inverse is given a name. What's the name called? Logarithmic, okay? That's really all it says. But what I need you to know is this. I need you to know that when you see a log problem, you just tackle it like this. You look at it, you say, what does log base a of x mean? Look over here. It just means take a to the what power? A to the y equals what? X. Well, if I do that over here, guys, here's what it does. A to the y, a to the y equals x. A to the y equals x. Exactly what they said it was. Okay? Right? Then this next part, they turned the y into function notation, just so you know it still works with functions. Okay? As I keep going, guys, I'll do this over and over. You'll see me do this little circle thing. A the base, raise it to the y power should give you x, what you took the log of. Okay? Now we're going to do this. We're going to convert back and forth. Okay? So right now I've given you two equations in what form? Yeah, they're both in log form because obviously they say log of this, log of that. Your job is to turn logarithmic form into exponential form. Okay. So let's get it in exponential form, and it comes down to this. Can you read a log problem correctly? All right. You look at it, you go, what base am I in? Okay, base 2 right here. And you have to understand when you go over here and you say 2 and then you say 3. This number 3 out here, guys, it's your what? It is your exponent. It is just an exponent. Okay, so that's all it is. It's 2, raise it to the third. You should get what? 8. And that's it. These are test questions. These are quiz questions. I need you to get out of log form into exponential, or exponential back to log. Okay? Everybody okay? Slide over. Do the next one. Chloe, have you got it done yet?
Yeah.
What is it?
The second one is a to the 4th equals 16.
Chloe says that. You say what? Yeah?
I say, good job, Chloe.
You say, good job, Chloe. Chloe, you got it right. Good job. Okay, and you know what? I'll just draw you a picture. The picture looks like this. I always start with the base. I say, take the base, raise it to the exponent, and you should get what you took the log of, 16. Anybody know the answer, by the way? 2. 2 to the 4th equals 16. Got it. That's it. Okay, now that's log form, convert it to exponential. Now let's do the opposite. Let's do exponential, convert it to log. Okay? There you go. Think about it. Harry, what do you have for 3 to the 4th equals 81? As a log equation, it would be what?
Log, base of 3 is 81 equals
Let's say the log. Log what?
4. Log 3,
Log base 3
81
of 81
equals 4.
equals 4. Yes or no? Yeah? Okay. He got it because really it's just base, raise it to what power? 4. Well, that's right here. And then you should get 81. And that's what it says. You should get 81. Okay. Gavin, what's the next one? 4 to the x equals 64.
Log base 4 of 64 is equal to x.
Yeah? Nod. Just nod. Okay, good. I got most of you going up and down. There's some of you still can't even nod. Okay? All right. Good. Now we'll go into what they call the most used logarithmic bases. Okay? So there's 2 bases that are used quite often. One of them is called the common log, and one of them is called the natural log. Let's talk common first. If you're in common log, it looks like this. Guess what? It's so common, they don't even put a base there. There's no base. But if there's no base, you're supposed to assume it's what? It's base 10. So when it's base 10, they don't put it. But you have to know it's there. Okay? And it's also so common that they programmed it in your calculator. So when you see the word log on your calculator, you know what base that is? 10. It is not base 2, it is not base 3, it's base 10. Okay, so now let's look at this problem. This problem, log of 100, because you don't see a base, the base is what? 10. Now this problem, I would like you to get the answer right here. But I don't want you to use your calculator. I want you to think about what it's saying. Hannah, you know? She says 2. Well, here's how I know if she's right. This really says 10 to the what? 10 to some power must get you what? That number. Hannah says the answer's 2. Is she right? She's right. Okay, that's it. So in other words, can you type that in your calculator? Will it work? Type it in. Hit log 100. See what it says. See what it says. Does it say 2? Okay. Guess what? if you can do these in your calculator, how am I going to test you on this? I am. I'm going to test you, but how am I going to do it? I'm going to tell you this. Here's your test, and I'll say this test is without your calculator, and then I'll go this test is with your calculator. So guys, if you think you're going to just type this stuff in and come up with answers and smile and think, hey, I know what I'm doing. No, you don't. Your calculator knows what it's doing. I want to know you know. So I'll have a portion of your test without a calculator and a portion of your test with. Okay? This one, you can do it in your head. You should be able to do that in your head. Okay, this one, you can't. Now watch. What's this other one called? It's not the common, it's called the what? The natural log. The natural log is this. It's right here. What base is it? It's base E. Now that is such a commonly used base. They don't call it log of X, they call it natural log. It's ln, and why they didn't do NL, I don't know. But it's the natural log of X. What base is this? It's E. They don't even call it log of X, they call it the natural log of X. Is it on your calculator?
Yep.
Yes, it is. And on your calculator, I believe the letters are capital L and then not small case. Now, here's what I want you to come up with. I want you to come up with this. What's the natural log of 6? Well, you know you're in base E, right? And by the way, base E, the letter E is roughly what again? 2.718, blah, blah, blah. So what I'm asking you to do is say 2.718 to what power is 6? There's no way you're going to come up with that answer unless you use what? Calculator. What is it?
1.792.
Right? Do you trust it? You trust it? Really? Okay. Trustworthy people. Hey, you know what? You're going to solve a ton of equations on that test. You better not trust them. If I'm you, I'm going to test it out. You know what this says to me? E to this power must get you 6. So in my calculator, I'd do this. I would take the letter E, raise it to the 1.792 just to see if I get what?
6.
6. Do I?
Yes.
Did you do it?
You don't get 6 exactly.
No, you get 6 point,
0.001.
which is so close to 6, right?
Well, it's
Now, if you want to get closer and closer to 6, guess what?
your number.
You got to go further up. You'll probably never get there because you'd have to go forever. All right?
Challenge.
Here we go. Oh. This next slide says, before you do the slide, look at what? Look at the properties on page 228. So would you please, off to the side of your notes, put the 4 properties. I should have given you room for this, but I did not. Here come the properties. First property looks like this. Number 1. It's probably better that you don't look at the properties. Just answer the question. Log base A of 1
Equals 0.
equals 0. Is that true? You know what that said? I'm going to keep doing that. A to what power equals 1? Well, there's only one exponent that will get you 1 every time, guys. It is 0. So, CC, you are right. It's 0. So, guys, you understand that what I'm trying to tell you is log of 1 base 12. What's the answer?
0.
Guys, log of 1 base anything is 0. That should not have taken that much time. What's log of 1? Base 120.
0.
There, that's better. It's 0. That's the property. Okay, property 2. Log of A. Base A. What? Okay. So Lester says it's 1. Is he right? A, raise it to some power, should get you what? A. Well, this A is A to the what? First. So doesn't it, isn't he right? A to the first equals A to the first? Yeah. He's right, that's it. So guys, what that tells me is if I go like this to you, log of 8, base 8, what are you going to tell me the answer is? 8 to the first is 8. That's how easy that is. Don't think too hard about some of these. Some of these are pretty simple. Okay. Next, 3. 3 is it's the inverse property. I believe the first one says, I think it goes like this: log base A of A to the x equals. What? X? Yes or no?
Yes.
Look at it. A to what power equals A to the x. The bases are the same, right? Doesn't this have to be the same as this? So it's got to be x. Okay. Now, here's the deal. Please look at this closely. And here's what they're trying to tell you. They're trying to tell you this. These are inverse operations. Would you agree if I covered this up? You're looking at a log base A, right? But now let me cover this up. Now you're looking at an exponential base A, right? So exponential logs are inverses. So if you have inverse functions, they knock each other out. Guess what you can do? Just cross out the two bases and you get what? You get x, that's it. So if I did this to you, log base 7 of 7 to the 5th. And you don't even have to think about it. It's base 7, they're inverse. The answer is what? 5. Okay? The other one would look like this. A to the log base A x. This is the other one. Listening. Okay. A, raise it to a power. Isn't that going to be exponential? A to a power? That's exponential. Now look at your exponent. That's logarithmic. That's base A. That's exponential. That's base A. Aren't they inverses of each other? You can just do what? Cross out the bases and the answer is what? X. Don't trust it? That's fine. I wouldn't trust it either because maybe I'm sitting there like you going, I don't know what the guy's talking about. He's crazy out there. You know what I do? I just say, well, let me try one. What if I give you something like this? 10, raise it to the log of base 10, and I'll say 100. Do you know what the answer is right now? 100. Now you don't trust me? That's fine. Watch this. 10, cover up the 10. Just answer that question right there. What's the log of 100 base 10? 2. What's 10 squared? Oh, the answer is 100. Wouldn't it be a lot easier just to do this? This is exponential, 10 to a power. This is logarithmic base 10. When these are inverse operations, cross out the two bases. The answer is what? 100. It's the same thing. That's the third property. The last property is so simple. Here's the last property. It's the one-to-one property, which says if you have the log equal to a log and the bases are identical, AA, and this is log of x and this is log of y, what has to be true? X and y are equal, guys. In order for that to work, x and y have to be the same number. Okay? That's the fourth property. We'll talk about that property tomorrow when you get back, because I don't even get to that slide. Okay? All right. Here, back up. Back up. And answer those 4 questions. You can't see it very well on your paper because it's so dark, but do your best. Let's see what we can do. Sorry about that background. That background did not do well on your paper. Better change orange to yellow or something. Okay. Here we go. Log base 3 of 3 to the 6 is 6. Now if you think about it, what's being said is 3 to what power equals 3 to the 6. Doesn't it have to be 6? Okay? I mean, if you think about it. Another way to think about it is, that's a log, base 3, that's exponential, base 3. You could have just did what? You could have just crossed out the two bases. The answer is 6. This one, the natural log of e to the 5th, Gary is what? Or Eddie is what?
I don't know what the button is.
What is it?
5.
5? He says 5. Yes, no? Okay, you know what? This is base what? E. It says e to the what is equal to e to the 5th. Again, it's got to be 5. Okay? Bottom one, bottom left. Jeff, what do you think it is?
No clue.
No clue. Aaron, what do you think it is?
10.
He says 10. Now this is one where you kind of have to trust the property. I see 4 raised to a power. That's exponential. Then in the exponent I see the log base 4. These are inverse operations. This and this. Cross out the 4s. Cross out the two bases. The answer is 10. Okay? So that's all trust. That's just trusting your properties. This one, this is e raised to a power, so that's exponential. Then look at the exponent. It's the natural log of q. What base is this?
E.
It's e. Hey guys, you got e to a power, that's exponential. You got natural log of base e. These are inverses. Cross out the two e's, the answer is what? Q. Done. Okay. Next slide. You're on your own. Try to get them. You have to come up with the answers. By the way, these answers are going to be exponents. Let's see how you do. This would be you working on a non-calculator quiz. Non-calculator quiz.
Yeah. 1 times 3.
Good. And you do? Okay. Good, good.
So, in order to get fractions, your exponent has to be
No.
So,
No.
no, 3 squares.
No. So we're
I wasn't going to get
Yeah.
yes.
Like, I have 4.
Yeah, there's no.
Yes. What was that? Negative 6? 110. No. Yes, that's right.
You're like, so you must know this sounds like half time.
You know, some people are just really lucky because they do a lot. They do numbers in their heads really fast, and because some of you don't trust yourself, you always type your calculator, and then you get really reliant on your calculator. So now that backfires on you right now. And then the other people that struggle with this are people that don't understand what this says. When you look at this problem, here's what it says. Base 3 to what? I don't know. But whatever that is, it should give me what? 1/9. Okay. Now, some of you don't even know where to start. It's kind of trial and error, just so you know. Here we go. Here's what I would do. I'd start with this. What's 3 to the 0?
One.
1. I want 1/9. I'm not there. So try something else. What's 3 to the 1st? 3. Am I getting closer or am I getting farther away? Okay, you're going the wrong direction. Don't do 0, then 1. You should do 0, then -1. What's 3 to the -1? 1/3 to the +1. Is that that? No, but you're getting closer. Keep going. 3 to the what? -2, which would be 1/3 to the +2. What's that? 1/3 times 1/3? 1/9. You got it. Okay, what I'm trying to do. Now, some of you are so good at this, you got that answer pretty quick. You hardly had to think. But then some of you just went, I don't know where to start. If you don't know where to start at 3 to the 0. And then just take off. Keep moving. This one, tricky because they gave you a decimal. I would not have worked with a decimal. What is 0.01? 1/100. Okay, what base am I in? 10. So you're thinking it's 10 to what power gives you what? 1/100. Okay? Again, you got to start somewhere. Okay, I hear too much talking. That's 1. You could try 10 to the 1st. That's 10. You're going the wrong way. You need to get small. 10 to the -1. 1/10. 10 to the -2. 1/10 squared, which is 1/100. There it is. It's this. It was -2 and -2, wasn't it? Here's the problem. You're going to get to this on the quiz, and if you don't start doing what I just did, try 0, try 1, try 2. Go backwards. Try -1, -2, -3. Keep going. You're going to be in trouble. And you're really going to get in trouble when the number is a fraction. Because sometimes it's in between integers, and those are hard. I'll get to those later, okay? All right. What's next? The graph. Yesterday you graphed exponential, today you graph logarithmic, okay? So the graph of a logarithmic function is, well, that's what we're doing. Y equals log of x base a. Okay. They talk about when you do these, come up with the domain and come up with the range. And I'll get into that soon enough. They also tell you straight up, x equals 0 will be your what? Vertical asymptote. Now guys, they're telling you things, but you have to come back to this slide and read this slide over and go, oh yeah, they told me it was going to be x equals 0. It is x equals 0. Keep looking. It always passes through what points? 1, 0, and A1. What's A? What's A? It's your base. So it's your base, comma 1. That's what it will always be. I want you to read the slide later, because it will make more sense later. Okay, here we go. I need to get rid of that shade. Okay. Here's an example. On your calculator. Nah. Let's just do it ourselves. It's better to do it ourselves. Graph that. Now here's the deal. This is what kind of function? Linear. You and I can do this in 2 seconds. This is what? Exponential. Okay. This is what? Logarithmic. So this is a log. Okay. It's actually the natural log, just so you know. All right. Just in case you didn't know. All right. So watch how quick you and I can do this. What does y equal x look like? A line goes through what on the y-axis? 0. What's the slope? 1/1, up 1/1, up 1/1. So basically, isn't this the line? Right? Y equals x. Good? Okay. Next, let's graph the exponential one. This one should be quick and easy because you did it yesterday. Make a couple points, couple good ones. What's a good number? 0. Ready? Put it in. What do you get? E to the 0. 1. What's another good point? 1. Put it in. What's e to the first? E. Okay. Now, one other thing. Do you know if this is growth or decay? E, is that bigger than 1 or is E less than 1?
Bigger.
Bigger. It's growth. So you guys kind of know what it looks like already. So here we go. 0, 1. Right here. And what's the other one? 1E. Here's 1. Here's 2. Here's 3. Where's E? Over 1. Up E. 2.7. Okay. So right by here. And you know it's growth, so it goes up and it rides the x-axis. So the horizontal asymptote is what? Y equals 0. That's yesterday. So what's today? Natural log or a common log. Okay. Now what base am I in right here? E. Okay, watch this now. If you're going to graph that, come on down here. Your teacher last year, your Algebra 2 teacher, did not ask you to graph natural log or common log functions. You know what they said? Get it out of that form, convert it to exponential. In exponential form, guys, how do you write that?
E to the y power equals x.
E to the y equals x. Now, if you're going to graph that instead of that, this is much easier, just so you know. So here we go. Let's make a couple points. Here they come. Put your x and y table down. All I want is a couple. Okay? So what's a good number to put in? And by the way, you're not going to put numbers in for x. Because then you'd have to solve for y. Put numbers in for what? Y. Like what?
0.
Okay, ready? Put 0 in. What's e to the 0?
1.
Put in what now? 1. What's e to the 1? E. Don't even worry about the third point. Here they are. Graph them. 1, 0 is right here. Where is E1? 2.7. So this is 2. This is 3. How about, whoops, here. And then 1. Right there. All right. So here's the deal. If you look at it, guys, just those points from here to here, those points from here to here, doesn't it look like a reflection? It's a reflection over y equals x. Now, that means they're inverses, right? Exponential and logarithmics are inverses. Now, here's my next question. You see your horizontal asymptote? What do these points do if they get reflected? It changes this to what? What's the asymptote here? X equals 0. Okay, so what happens with log equations? Are you listening now? If you go back up here, it says they'll always cross what? 1, 0. And they'll always go through what points? A1. Where's the A come from? Whatever the base is. Okay? Now, you're not quite good enough to steal that information. I think you guys should be doing this right away. And that is, convert your log or convert all log equations to what? Exponential. And just jot the points down. Then you'll go, oh yeah, that's it. And then you'll remember this 2 days from now. Because if all you do is steal the information, you won't remember it. All right? Good? That's how you graph. That's how you graph x or logarithmic right there. Okay? Here we go. We got 5 minutes. We're going to get this money. Last problem we're going to get done. It says here, use the what graph?
Parent graph.
Parent graph. And transformations to graph this one right here. Okay? Then identify domain, x-intercepts, vertical asymptotes, and so on. Okay? So let's do it. Ready? Here's the problem. Most students have a hard time with the parent. The parent is the most basic part of this function. F of x, we're going to say y instead equals. Is that a log equation or is that exponential? I think it's obvious. It's what? Log. So you say y equals log. Okay. I want the parent, the most basic people. Base 3 of x. There you go. That's it. That's all you had to write. This is the parent. We're going to graph it. And then what are we going to do? We're going to shift it. Okay. So let's graph this. Now, if you listened to the previous slide, you already know the points. But I still say we're not good enough yet. Let's actually get the points ourselves. Change this to what? Exponential, which would be 3 to the y equals x. Quickly create a little table, and I mean little, like 2 points. Give me a number for y. Yeah, always 0, then probably 1. Ready? What's 3 to the 0? 1. What's 3 to the first? Okay, go graph 1, 0, which is easy. It's right there. Go graph 3, 1. It's right there. Just so you know this, if you go back to the previous slide, I did these same exact points. I did 1, 0, and I did E1. This time I did 3, 1. There you go. Do you know what it runs into? Yeah? No? Do I just keep going this way forever? It runs into a vertical asymptote, guys. What was it? Wasn't it the y-axis? Now, if you don't trust me, you're going to have to put in a whole bunch of x's. This is what? This is log base 3 of x. That's what it is. Okay? Now, you have to do this one. You got to do this. Now, you do see inside parentheses, you got a -4, so what's this? What's this going to do? Right 4. Take your parent, go right 4. What's this going to do? Vertical stretch of 2. Uh-oh, bell just rang. I will finish this problem right now, and then I'll put it on YouTube. But I will start here tomorrow again. You might struggle with graphing because you didn't see this problem. But I'll show you on the YouTube. Just go to this slide.
Sounds exactly like, isn't it? Also, like,
Time to push my music.
Yeah. Come up with the
Shift to
time.
neutral.
Oh, you're coming in Wednesday, 7 hours. You win, honey. Gotcha. Thank you.
And it saves a little bit.
Just neutral all the way down the ramp.
Hey guys, listen to this slide tonight, and then I'll finish it up right here. I'll stop here. Yeah, do that. And I'll help you a little bit, okay? Fine, sure, I'll see you Wednesday, 7 hours. Right? Okay. All right. I'm gonna finish this slide, girls, so ignore me. Okay, from here, we move the parent graph 4 to the right. So this point, 1, 0 would move right here, and it would be 5, 0. This point would move 4 to the right. Oh, I said that wrong. 5, 0. But when you stretch it by 2, since the y value is 0, you cannot stretch it by 2. So this will stay here. This next point will move 4 to the right. 1, 2, 3, 4. But then you have to stretch it by 2, so you're up 1. Now you're going to be up 2. And there goes the graph, just like that. Now, one other thing. Your vertical asymptote also moves 4 to the right. So 1, 2, 3, 4 to the right. Here's your new asymptote right there. So x equals 4 is the vertical asymptote. Okay. The x-intercept is now 5, 0. Okay? And the other thing they asked you to find, if you read through this, is the domain. Identify the domain. So the domain will be all real numbers that get, I should say this, all real x values that get answered. So what got answers here? Well, looking at it, 5 got an answer. 7 gets an answer. This gets an answer. This gets an answer. But also anything to the right of the vertical asymptote. So you'd say all x's that get answers will be greater than 4. And that becomes your domain. That ends that slide. I hope you got something out of that period 6.